Hi students, today we are going to discuss about the electric dipole and the electric field on the axis of the dipole. So in the last class we discussed about the electric field lines and what is the electric field on a point due to a system of charges. If you have not yet watched the video, I will put the link in the description. Just go and watch it. Now I am going to define what is meant by electric dipole. So the electric dipole is the two equal and opposite charges separated by a very small distance. It's called electric dipole. So two equal and opposite charges, which means two equal magnitude and opposite direction charges. So I have a positive charge here and I have a negative charge here. The separation between the charges is very small. So for the calculation purpose, the separation between the charges I am going to take it as a 2a. This charge is q magnitude, this charge is also q magnitude, but this is a positive charge and this is a negative charge. So now two equal charges separated by a very small distance. So now I am going to define a new quantity called a dipole moment, the electric dipole moment. So the dipole moment I may define, it's denoted as a P. So what is electric dipole moment? So I may write here, first I will give some example here. So if I have a bar magnet, this is the north pole and this is the south pole. If I have north pole and south pole, my magnetic field lines always starts from north pole and end with the south pole. Okay. So what's happening inside the magnet? Inside the magnet, your field lines will flow from south to north. This is very important, right? So in the field lines inside the medium, it is going south to north. And then I have similarly I have a dipole. This is positive charge and this is the negative charge. If you have positive charge and negative charges, so the electric field lines start from positive and end with the negative charges. This is called your electric field. So what's happening inside the dipole between your negative and positive charge? So inside the dipole, my electric field lines is flows from negative to positive charges. So the electric field between the dipole, between the two poles of the electric dipole, it's called your dipole moment. So dipole moment is the vector quantity. Your P is the vector quantity. So it is always flows from negative to positive, right? And then it's depending upon what my electric dipole moment, which is directly proportional to the magnitude of the charge. See, I have for example, I have a plus 5 coulomb and minus 5 coulomb. Now it's a dipole. So my plus 5 coulomb and minus 5 coulomb, they are going to attract each other. So the amount of work done required to separate these charges will be some x. Next case I have a plus 10 coulomb and minus 10 coulomb. Now I am going to combine these two. If you combine these two, I have to do more work compared to my previous case, because if the magnitude of the charge gets increases, the interaction between the strength of the dipole also gets increases. If the strength of the dipole gets increases, I have to do more work to separate them. So your dipole moment is nothing but the strength of the dipole. So my dipole moment is depending upon the magnitude of the charge. If you want to replace this proportionality symbol by a constant, I am going to replace a proportionality symbol by a constant. Is nothing but P is equals to 2a into q. 2a, I already told you, a proportionality constant which is always tells about the nature and dimension of the system. In this case, the distance between these two is called 2a, 2a q. What I told you, my dipole moment is a vector quantity. If you want to put vector here, I need a unit vector here. My P cap is called your unit vector. right? So next I am going to explain what is the electric field on the axis of the dipole due to the given dipole. So first I am going to start with electric field on the axis of the dipole. So first I am going to start with this is my positive charge here. I have a negative charge here. The separation between them is going to be 2a. Okay. So my dipole moment is always from negative to positive, right? So my electric field lines due to a positive charge is always going outwards. My electric field due to the negative charge is always going inwards. So on the axis of the dipole, I just want to find the electric field at point some x. So at this point, I just want to find the electric field due to this dipole. So I have to take the distance from the center of the dipole. So I have to take the distance from the center of the dipole. The distance from here to here is going to be r. Okay. So first I am going to write the electric field at point x due to this plus q is in this direction. This is my electric field due to your plus q. Okay. So now I just want to write the distance from here to here is going to be r minus a, right? Because the separation between them is going to be 2a. The distance from the center is going to be a. This part is another a. So I can simply write here the distance from here to here is going to be a. The distance from here to is going to be again a. So r minus a, I am getting the distance from here to here. So first I am going to write the expression for the electric field at x due to first plus q charge. So E plus q equals to 1 by 4 pi epsilon naught q by r minus a. Okay. R minus a, so r minus a the whole square. So up to this point, this is just a scalar, this is just a magnitude. So I need a unit vector. So I am going to place my p cap. See, listen, my electric field is going outwards, my dipole moment is in the same direction, that's why I put plus p cap. Listen carefully, I am telling you, my electric field due to plus charge in this direction E plus q. My dipole moment is also the same direction. That's why these were the parallel vectors. That's why I put plus p cap here. So next, I am going to write the electric field at point x due to this negative q. So my electric field due to a negative charge is always coming inwards, right? So I can simply write here, if this is in this direction, E minus q vector. So now I am going to write the electric field. First I should know the distance. So the separation from here to here is going to be r plus a. So this is r and then plus this distance is my r plus a. So I can simply write the electric field at x due to minus q. E minus q vector 1 by 4 pi epsilon naught q by r plus a the whole square. Listen carefully, don't use minus sign because of this minus q, plus sign because of this plus q. This is not because of the plus q or minus q, this is because of that direction of the unit vector. Listen carefully, here my electric field is going this direction. So my electric field due to a negative charge in this direction minus q vector, minus q in this direction vector, and then your dipole moment is in the exactly opposite direction. So my dipole moment is in the exactly opposite direction. So these two vectors are the anti-parallel each other. We put minus p cap here. So if I put minus p cap here, so now I just want to write the resultant electric field at point x. So the net at x, E axial, okay, E axial point 1 by q by 4 pi epsilon naught 1 by, listen, this is minus sign, right? 1 by r minus a the whole square minus 1 by r plus a the whole square p cap. Okay, so this is my electric field on the axis of the dipole. The thing is, I need a compact equation. Okay, so I need a compact equation. I'm going to expand this term. So I can simply write here q by 4 pi epsilon naught, if I cross multiply these two, r plus a the whole square by minus r minus a the whole square, r square minus a square the whole square. Okay, a plus b, a minus b. So into we have a p cap in the both terms. P cap we have, right? So I'm going to expand this in terms of a plus b whole square. This is in terms of a minus b whole square. So after simplifying this equation, I'm getting E axial equals to 2 into 2a into, actually 4a will come, 2 into 2. Okay, I'll show it how to expand this. Okay, so E axial equals to q by 4 pi epsilon naught r square plus a square minus 2 into a into r, and then minus r square minus a square plus 2 into a into r. This is going to be, yeah, this is plus and this is also plus, divided by r square minus a square the whole square. So in this case, my r square gets cancelled. This is a square gets cancelled, and we have a 4ar. This is going to be q by 4 pi epsilon naught 4a into r by r square minus a square the whole square into p cap. So this 4 split into 2 into 2. Okay, then I can simply write this equation 2 into 2a into q is nothing but p 4 pi epsilon naught r minus a the whole square, r square minus a whole square into p cap. So 2aq is called p, is a magnitude of the dipole moment, into p cap is going to be your p vector, and then for r is very much greater than your a. So this is the approximation we are taking, because a is the 2a is the distance between the two dipoles, two poles of the dipole. So it is very small value compared to the r value. So I can simply rewrite this equation as two p vector by 4 pi epsilon naught r cube. So this is the electric field on the axis of the dipole. So this is a vector and this is also a vector. So this is positive and this is also positive, which means the electric field at point x, this is in this direction, along the direction of the electric dipole moment. So this is also positive and this is also positive, because both are in the same direction. So my E axial in this direction. Okay, my E axial in this direction. So why it is in this direction? Because this is nearer to the positive charge. Because of the nearer to the positive charge, the influence of the positive charge will be larger than the influence of the negative charge. If you like this video, share with your friends and subscribe our channel for the more content. So we have a practical videos in our channel in a separate playlist. If for your board exam you can utilize it, and then if you have any feedback and if you have any doubts, just write in the comment box. I will try to conduct a special session to clear your doubts. So, okay, thanks for watching. We'll meet in the next class.